The first example we're going to do from the problems at the end of the chapter or a section. We have two complex numbers, oops, missing a parentheses here, in polar form, and we just want to compute the product and quotient. And we're going to do so without doing a lot of work. So we know a couple of things. We know that the argument of the product is the sum of the arguments, where we take sort of all rotations into account when we write that. And we know that the product of the moduli, or the modulus of the product is the product of the individual modulus. So what this is telling us then is that, well, since the argument of z1 is pi eighths, we take pi eighths and we're going to go ahead and add that to the argument of z2, which is 3 pi eighths. Now, technically, I should put all multiples of 2 pi here, but I just want to write this guy in polar form, so I don't actually care about all the multiples of 2 pi. They go away. So we get 4 pi eighths, which is pi halves. Moreover, the modulus of z1 is here. It's 2, and the modulus of z2 is 4. So this is 2 times 4, which is 8. So this tells us that z1, z2 is going to be 8 cosine of pi halves plus I sine of pi halves. So that's 8. Just, you can leave it like this, that's fine, but cosine of pi halves is 0, sine of pi halves is 1. So that's just 8i. And we could have, again, sat here and just multiplied these out, but we know some information about polar form and how it behaves with respect to multiplication. And so this is a little bit cleaner than multiplying it out and dealing with trigonometric identities and whatnot. All right, so that was the product. Now let's do the same thing but for the quotient. So what do we know about quotienting? We know that the argument of a quotient is the difference in arguments. Of course, this is for z2, not 0. And we also know that the modulus of a quotient is the quotient of the individual modulus. All right, so we know the arguments for each one of these. I'll go back up to remind myself. Actually, I think I got it. I think the first one was pi eighths, and the second one was 3 pi eighths, but feel free to rewind and to double check me. Again, we should take this with respect to all multiples of 2 pi, but in terms of writing z1 over z2 in polar form, it doesn't actually matter. So I think this is minus 2 pi eighths, which is negative pi fourths. So that's the argument of the quotient. And then also we have z1 over z2, the modulus of that. I believe one was 2 and one was 4. So that's a half. So this is telling us then that at least in polar form, z1 over z2 is r, which is a half, cosine negative pi over 4, plus I sine negative pi over 4. And again, we can leave it like this if we want to, or we can compute these values. These are special angles. This is actually going to be a negative, because sine of negative pi over 4 is negative root 2 over 2. And then if we're going to plug that in, we might as well multiply the 1/2 into both sides. So here's our difference, or our division.